Hello, and thanks for watching my final video, at least at this point, that will explain how to do some of the questions from the GMAT official guide, the diagnostic test, and what this video will discuss is question number 15, and then the final question, which I think is question number 24. For those of you familiar with my videos, again, from the GMAT training manual, the table of contents, we do have a top 14 trigger we're going to talk about, any kind of large number or products or decimals. You're going to want to know, generally, you're going to want to prime factor and recombine terms. We're not going to really do that here. We are going to look to use 10 to the x. They love this 10 to the x and 10 to the negative x stuff. Put another way, number properties from my table of contents. Anytime you have decimal places, which we don't here, or large numbers, which we do, we're going to use 10 to the x. It's a classic trigger, a large number, to use 10 to the x. And that's what you're going to see here, the product of all the prime numbers. Whoa, that's going to be big. So let's enlarge this a little bit. And again, just as a reminder real quick, what this video will demonstrate is how a graduate of my UQR course, again, not quite available sometime in 2012, how a graduate of my course would attack this question with ruthless efficiency. Oops, sorry about that. Let's check this out. Okay. So, the product of all prime numbers less than 20 is closest to which of the following powers of 10? Well, first of all, my students would know to definitely look at the answer choices to understand, okay, so what they're really asking for is how many tens are going to be in this product. So definitely look, I mean, we have to write out all the prime numbers less than 20, which is not that many, not a big deal. We have 2 and 3 and 5 and 7 and 11 and 13 and 17 and 19. Okay, now look, you could definitely just go ahead and multiply all these together. There's nothing actually wrong with that, and then make an estimation, and you'll see you'll get to the answer. However, there's always going to be a more efficient way to work from the GMAT. And that's, of course, what we're going to discuss here. The first thing you should notice is that some of these numbers I can actually multiply fairly easily. I mean, this is 6, and then multiplying that by the 5 is going to be 30, and then multiplying that by the 7 is going to be 210. Okay. The other thing we want to do is, because we're dealing with powers of 10, because our answer choices are dealing with tens, we want to figure out how many tens do we have in here. And my UQR students would know how to manipulate that fairly easily. So like, for example, this first term here, we have 10 squared times 2.1, right? For 11, we have 10 times 1.1. For 13, we have 10 times 1.3. For 17, we have 10 times 1.7. And for 19, we have 10 times 1.9. So we're just figuring out generally how many tens we have in here. So here I have 1, 2, 3, 4, 5, 6. Excuse me, 6 tens. So let me just do that again. 1, 2, 3, 4, 5, 6 tens. So at this point, I have 10 to the 6, but then I also have these other numbers, right? I have this 2.1 and this 1.1 and this 1.3 and 1.7 and 1.9. So it's also going to be 10.6 times 2.1 times 1.1 times 1.3 times 1.7 times 1.9, which you might think, well, I don't want to multiply those together. We don't have to. We just have to figure out, is all of this going to give me another 10? And that's definitely going to give us another 10, right? I mean, this is already a 2. And then if we multiply all those together, that'll give me roughly maybe 4. So that'll roughly give me 8, which is roughly another 10. Because they're asking to us to approximate. So we have a 7th 10. So we have 10 to the 6th times 10, which gives us 10 to the 7th. Answer choice C. So they do like these approximations on this test. My students know that, and they know how to manipulate the idea of not just 10 to the negative x with decimals, but also 10 to the x, and how to approximate using these types of scientific notation. So I hope that was a help. And again, you don't have to do it that way. You could certainly just multiply out all those numbers. But almost invariably, the GMAT will provide another way in which to approach these questions, and this is that other way. Oakley dokley, let's take a look at the final question of the diagnostic dealing with Aaron. So, getting rid of that. Oh, there we go. Okay, so once again, GMAT official guide. We're now going to take a look at the last question, question number 24. Before we do that, the GMAT training manual, the table of contents. I do have a top 14 trigger. Cheating back down to the question a little bit here. Notice he's jogging and he's walking, okay, and he's going per hour, per hour. So that's our trigger is per. Anytime they say the word, use the concept of per, like percent or per mile or per person or per pound or per minute or per hour, per job, I have this killer 3-part grid that we can use, okay? More specifically from the table of contents, we have these proportions here, and you're going to see we have rates involving distance. Okay, rates involving distance. That's what this involves. And there's a very specific setup for this question. Notice, by the way, we have variables in the answer choices, and we could certainly pick numbers here if we wanted to, but there's no need for that at all, because when you have a per, when you have rates, there are just much better ways to approach the question, and that's what I'm going to show you right now. Let me kind of get a better, there we go. Okay, so let's read over this question more carefully. Aaron will jog home at X miles per hour, there it is, and then walk back home by the same route at Y miles per hour. How many miles from home can Aaron jog so that he spends a total of T hours jogging and walking? Okay. Well, what we can do is create this really awesome distance equals rate times time grid. We know, right? A distance is equal to a rate times a time. And in fact, what we can do is create this, what I call this 3-part grid. And this is used throughout the test, not just with rates, but with work and averages and percents and costs and wages, all kinds of thrilling stuff. And all we're going to do is a basic 3-step method. The first step is to set up the grid and fill in the easy information. So what do I mean by the easy information? Well, so he's going to jog and then he's going to walk. And he's going to jog one way and then he's going to walk the other. And I know his jogging, his rate is X miles per hour, and his walking rate is Y miles per hour. We also have the total, because it looks to be some kind of round trip, right? He's walking home and then he's walking back home, right? So he'll jog home and walking back home. So our total is going to be T, because that's what it says. It says he spends a total of T hours jogging and walking, so that's our total. So that's the first step, is in creating the grid, just fill in the given information. Step 2 is to take account of the implied terms and assign variables. And this is where things can get a little bit tricky. In other words, we haven't talked anything about the distance. And what they love to have here is sometimes having the distance or even the time or even the rate being the same. And here our distance is the same, right? Because he's jogging home and then walking back home. So it's got to be the same distance. So it's got to be D and D. That's how I'm going to assign the distance. So step 2 is to assign variables for the implied terms, keeping in mind that very often the terms will be the same. They don't have to be, but very often they will. That's step 2. Step 3 is to now manipulate the grid. What do I mean by manipulating the grid? Well, I know, once again, going back up to the top here, a distance is equal to a rate times a time. If that's the case, then I can take this D here and this X here, and I can divide, and I can end up with D over X. In addition, I can take this D here and this Y here, and I can divide and get D over Y. So I know that this represents the time for him jogging, this represents the time for him walking. I also know that when I'm given any kind of totals, like here, I can add, right? Because I know if this is his time for jogging and this is his time for walking, then this has to be the total time between the two. So I can create an equation where I have d over x plus d over y equals t. So it's like, wow, what the world am I supposed to do now? Well, you know what? I always keep an eye on the answer choices, right? My students are trained to always keep an eye on the answer choices. And if I look at the answer choices, that's going to tell me, oh, I'm supposed to solve for D. I have to solve for D, right? Because there's no D's in my answers. There's all X's, Y's, and stuff like that. Just for the heck of it, I'm going to show you how to solve this because there's a little trick. When you have fractions, like this, you can always just multiply through by a common denominator. I'm going to multiply. Anytime I have an equation with fractions, I'm going to multiply by a common denominator each term. And I'm going to multiply each term by xy. So if I multiply this first term by xy, I'm going to do the whole thing out just for the fun of it. Yay. I have dxy over x plus dxy over y equals txy. And then working from there, notice what cancels. The x's cancel, the y's cancel. So I have dy plus dx equals txy. And even if now you don't know how to factor, I have this trigger of a repeated variable. I talked about that in my very first video for my free preview. So if working that, I can factor out the d times y plus x equals txy. Oh, now I see how to solve for d. d equals txy over x plus y. And where is that? Oh, that's going to be answer choice C. Okay, so knowing how to work these fractions quickly and efficiently is always going to be a help. But more importantly, going back up this grid, okay, this grid can be used not just for rate questions, but for working together, for averages, weighted averages, mixture questions with percents, dilution or evaporation with percents, or even if they talk about multiple wages or multiple costs. What my students learn is how to use this grid here for all of those question types, and it is very, very effective, if I say so myself. Oakley dokley. Well, that brings us to the end of my explanations for dealing with some of the trickiest questions on the GMAT diagnostic test from the official guide. I really do appreciate your time. I hope that this video was able to help you in your GMAT studies, and definitely good luck on the GMAT. Thanks for watching, and hopefully you'll check out my other videos when they come online. Thanks.